Today's lesson is 5.2, Solving Radical Equations. Let's go ahead and take a look at example 1, which is asking us, is x equal to 5 the solution to the equation, the square root of 2x plus 15 equals 8? All we need to simply do is take this value of 5 and substitute it into this equation where we see the variable x. Remember, whenever I substitute, I need to use parentheses. Okay, let's go ahead and get started. So I'm going to do my square root, and I'm going to do 2 times 5 plus 15. And I just want to keep asking myself, does that equal 8? I just want to keep asking myself, does that equal 8? Okay, well, 2 times 5 is 10. So under my square root, I have 10 plus 15, and I'm going to keep asking myself, does that equal 8? 10 plus 15 is 25. Does the square root of 25 equal 8? If you're not sure, pop it in your calculator. The square root of 25 is 5. Is that equal to 8? No. So this is not a solution. I should have gotten 8. All right, let's go ahead and take a look at example 2. Now they are asking us simply to solve this equation. The square root of 2x minus 5 plus 7 is equal to 16. Much like how you used to solve regular equations without the square roots, we're going to go ahead by starting by adding our line through our equal sign. Now I'm making it a little bit lighter because if you're good without it, if you're good keeping track of your equal sign, that line doesn't have to be there. I want to get x by itself. My goal is to get x by itself. I see lots of things bothering it. There's a 2 right in front of it. There's a minus 5 right behind it. And both of those things are under the square root. I also see a plus 7 after it. I have to get rid of each one of these separately in the order and follow the order of operations backwards. So I'm going to go ahead and start by subtracting 7 because it's outside the square root. So the first thing I'm going to do is subtract 7, leaving me my square root and my 2x minus 5 is underneath it, and 16 minus 7 is 9. Now the next thing I need to get rid of is the square root. Because the 2 and the 5 are underneath it, I have to get rid of the square root before I can get rid of the 2 or the 5 that's next to my x. To get rid of a square root, I do its opposite, which is squaring. When I square this side, I get 2x minus 5. What I do to one side of an equation, I must do to the other. 9 times 9, right? 9 squared, 9 times 9 is 81. Now I simply have this two-step equation to solve. So I'm going to go ahead and add my 5. '81 plus 5 is 86. And I go ahead and I divide by 2. X equals 43. Before I can go ahead and say that this is my solution, I need to go back and I need to do the check. Okay, I need to go back and I need to check it. Remember how we used to teach you to check it in Algebra 1? There's no reason to get these problems wrong because you can always go back and check them. So basically, you're just going to go back to the beginning and you're going to say 2 times 43 minus 5 under the square root plus 7. What does that equal? Does that give you 16? Now notice I'm not asking myself this time. I'm just going to go through and do the work. Okay. All right. So I've got 86. 2 times 43 minus 5 plus 7. 86 minus 5 gives me 81 under the square root plus 7. The square root of 81 is 9. 9 plus 7 is 16. It checks out. 43 is my solution. Now, you might be thinking, why did you do that, Miss? Why did you go back and check it? Well, that's because you need to always check your answers when you are solving a radical equation, when you are solving a square root, because sometimes you will solve an equation, get a solution, and when you plug it back in, it's not going to work. So I could have gotten an answer there that was not equal to 16. That solution, or when this happens, they're called extraneous solutions, and they are not actually considered solutions to the equation. Yeah, they work when I do the first part, but when I go back to plug it into the original, it doesn't work, and so I do not consider it an answer. To help me find these, I got to make sure that I do the check every time. All right, so let's take a look at this next example, and we're going to come up to see when I have an extraneous solution in one of my last two examples. Okay, 3 times the cubic root. Notice right here, I have a little 3 inside the root, the radical. This is a cubic root, not a square root. X minus 8 minus 2 equals negative 14. We're going to go ahead and draw our line through the equal sign. There we go. And we're just going to go ahead and start getting rid of stuff. Remember, we got to get x by itself. So there's a 3 in front of it. There's the cubic root. There's the minus 8. There's the minus 2. I need to make sure that I get rid of them in the proper order. So I'm going to get rid of the minus 2 first. Then I'm going to get rid of the division by 3, or the multiplication of 3. Then I'm going to get rid of my cubic root. And last, I will get rid of the minus 8. Here we go. So let's go ahead and start by adding 2. Now it is negative 14. So I've got, hold on a sec. Oh no, let's keep it because I got to get that, remind myself it's a cubic root. 8 minus negative 14 plus 2 is negative 12. Okay. Now I'm going to go ahead and I'm going to divide by 3. Divide by 3 to get rid of the large 3 in the front, leaving me with my cubic root. And negative 12 divided by 3 is negative 4. Now, much like I got rid of the square root, I'm going to do the same thing to get rid of the cubic root. But this time, instead of squaring it, I need to cube it, because cubing gets rid of a cubic root just like squaring gets rid of a square root. What I do to one side, I must do to the other. This simply gives me x minus 8 on this side. And what I'm going to be doing over here when I cube is negative 4 times negative 4 times negative 4. Negative times a negative times a negative gives me a negative. 4 times 4 times 4 is 64. I put it in my calculator. Now all I simply have to do is add 8 to the other side, add 8 to the other side, and I get x equals negative 56. Remember, before you go ahead and put this answer into Alex, you got to go back and you've got to check it. You've got to go back and you've got to check it. So we're going to say 3 and the cubic root and then we're going to put in negative 56 minus 8, and then outside the square root we're going to subtract 2. We're looking for an answer of negative 14. Okay, I'm plugging in for this side, and I'm looking to see, do I get negative 14? Okay, 3 stays in the front, my cubic root, negative 56 minus 8 is negative 64. And of course I have minus 2 out here. The cubic root of negative 64, the cubic root of negative 64 is negative 4. I could put that in my calculator. 3 times negative 4 is negative 12. Negative 12 minus 2 is negative 14, and I match. This is a solution. It is not an extraneous one. Okay, so we need to do one more example so that you can actually see what an extraneous solution looks like. Here's our last example. Solve the square root of 4x minus 1 minus x equals negative 1. Let's go ahead and get started. Draw that line because it is quite helpful. Oops. And here we go. The first thing I would do is move that x to the other side. I know that seems weird because you have an x, but trust me, that's what you want to do first. Now I have the square root, okay, that's much nicer, of 4x plus 1 on this side, and I have x minus 1 on that side. To get rid of my square root, I'm going to go ahead and square this side, which gives me simply 4x plus 1. What I do to one side, I must do to the other. When I am squaring this, I'm actually doing that. So remember, we talked about this a little bit in the last lesson. You're going to draw your box, and you're going to use the box method to multiply x minus 1 times x minus 1. X times x would be x squared. Negative 1 times x is negative 1x. Negative 1 times x is negative 1x. And negative 1 times 1, negative 1 is positive 1. My like terms are going to be right here, and the box is telling me to add them. So here's what I have for an answer. X squared minus 2x plus 1. Now you might be thinking, did I really have to do that? Yeah, you did. Now we're going to go ahead and we're going to take the 4x plus 1 and we're going to move them over here to this side with the square. So minus 4x, and that can be combined with the minus 2x, minus 1, and that can be combined with the 1. I end up with 0 on this side, and I end up with x squared minus 6x, and then I have plus 0 because these two cancel out. I did that in my laser because I don't need it. It doesn't have to be there. Whenever a quadratic appears, you must factor it to solve. You must factor it to solve. Because this quadratic does not contain a C value, I can factor out the GCF. What do both of these two terms have in common? They both have an x. So if I factor an x away from x squared, what do I have left? I have x. I put a minus because that's what's here. And if I factor away an x from 6x, what do I have left? Well, I have 6. There's my factoring, okay? Now I'm going to apply the zero product property. And that's the one that says either this term has to be 0 or this term has to be 0. So one of my answers could be x equals 0. My other answer, or x minus 6 equals 0, I have to solve that one by adding 6 to both sides. My second solution is x equals 6. Now, both of these could be answers, or neither one of them could be answers. We just have to go ahead and we have to check. Okay, we're going to go back to our original equation, and we're just going to plug it back in. So let's plug in the 0, because that one is super easy. 4 times 0 is 0, plus 1 minus 0. Okay, I get the square root. 4 times 0 is 0, plus 1 is 1, minus 0. The square root of 1 is 1, minus 0 equals 1. Let's go back up and look, because I forgot what it was equal to. Oh, look, I needed negative 1. This is not a solution. This is not a solution. This is what we would call extraneous. Let me spell it right. I would not put this into Alex. Now, could the other one be extraneous? Yes, yes, it could. So you need to go ahead and check it as well. Don't just go ahead and put it in because it could actually be extraneous as well. So 4 times 6 is 24 plus 1. Yep, there we go. So 24 plus 1 is the square root of 25 minus 6. So that's 5 minus 6, because the square root of 25 is 5, negative 1. And that does match up above, so this is my only solution.